So with core software development, one of the things that we've added more recently is time zones and software and dealing with time. As you get into dealing with time, unfortunately, all of us think about time in the current time zone we are in and lose relativity. And the other thing that happens with time zones that's kind of odd is when you start debugging things, if you're debugging them across time zones, it becomes very easy to quickly forget that and get led astray looking for something at 3 p.m. Eastern time when it's, in Central time and, an hour off in your logs, and you can be lost trying to find the wrong problem or going down the wrong rabbit hole very quickly. And so one of the practices that we typically do in software is from a software standpoint, we store all times in UTC. Doesn't mean you display them in UTC, but you can display them in whatever time zone the user's in, but you store them in UTC, so it makes it easy for traceability, easy to compare, especially for log messages. Put all of your log messages in UTC so that when you want to find something, you might have to do some conversion, but then all of a sudden your logs are all on the same time zone. You're not trying to figure it out. And well, this server is logging in Eastern time, server 3 is logging in Mountain time, and then server 4 is on the West Coast, so it's West Coast time. Can you imagine trying to figure out my server and the logs? So unless you really hate yourself, I'm sure you've dealt with this, Dustin.
Literally this past week, we had an issue with our where we have 5 different application development servers that are deployed, and the logging we use
my camera's fixed.
We use the Elk stack for logging and doing our monitoring, and the time zones were not the same once they got to Elk. It was very interesting as you're sitting there troubleshooting, looking at the logs of the application and seeing one time zone, and then looking at and trying to debug the problem from the application monitoring perspective, and they're in a different time zone. So when you get a bunch of logs into the system, it starts to slow down a bit. So doing queries in this system is, quite slow. So anytime that you have to go and change your time zones or change your time ranges, when you're trying to, debug a problem, it can take upwards of 10 minutes just for it to run the query.
Well, and then if you don't trust what the information you're getting in your logs, what good are they?
Yeah.
The logs are our developer insight into things. And now if it's well, if the times are all wrong, you don't know. You're all of a sudden you're like, what stack trace am I debugging?
Mm-hmm.
It's useless at some point, and then that's incredibly frustrating.
Yeah, especially because, and then the other thing that we were running into as well is that during the time zone that I thought was right, there were other exceptions happening there. So then it's you're chasing down these other rabbit holes that don't necessarily map to the problem that you're trying to solve. So
no, that never happens.
No, never.
Daily. So anyway, we just want to make people aware of time and time zones. Be thoughtful about it, and also don't lose sight into displaying times and time zones with users. They don't want to do things in UTC time, so don't force them to do that. It's all about the experience. So that kind of leads us into talking about logging frameworks. Mm-hmm. We're very passionate about logging frameworks. A lot of people prefer the system.out.println or console, or pick your favorite, mechanism to print things to the screen in your favorite language. The problem with taking that approach is now you're compiling this into the code. So you have to compile the code, deploy the code, and run the code to make a change. And then like all developers, right? When it works, what do? We throw our arms up, we celebrate, right? And it's usually Friday at 5 p.m. So we run out of the office happy as anything, right?
Yep. Leave it in there.
Yeah, the following week we deploy the code, and operations is wow, our logs are filling up with all these random weird messages that don't mean anything to us. And so
they're not coming into the normal log file either.
Yeah, they're going to the console. And then it usually never happens during the day. It's always some weekend, a week later, the hard drive fills up with the logs, and then they ask what's in the logs, and they track it back to
users figure it out.
One of us.
App isn't working anymore.
Yeah,
the logs filled up.
So instead, we want to use logging frameworks, because what they allow us to do is they allow us to go to a configuration file, turn on and off the logging for a specific class or for a specific area. Okay. And that allows us to be, methodical about our debugging. The other thing that they do that I really like is that they allow us to add value to the code. So if Dustin here adds some debug in, it can stay in the code. And then somebody that picks up the code and supports the code later, if we put quality log message in there, so make sure you don't just put A or something in there, put, a little readable context so that you understand what the values are printing out, what the context of the code is, so that then when somebody else comes along, there's value in those log statements. So you're increasing the value of the code. Now, it's not perfect, right? What I typically find happens is Dustin will put log statements in, I'll take over his code, and then it'll get me really close and I'll need some more data. So I'll go in there and I'll modify the log statements, which, that'll have to cause a recompile and everything deploy. But by the third developer, when Pat over here gets to doing it, it's going to be perfect. He's going to be like, oh, wow, this is awesome. We've refined it. We've added value by putting that logging in there. So there's actual value in getting log statements in there.
Yep.
So the other thing that happens with log frameworks is you get all the functionality of the frameworks for free. We don't have to go write our own logging framework. It makes no sense. There's plenty of good ones out there, so please don't go reinventing the wheel. I think from a Java standpoint, SLF4J was a rewrite of the log4j because they learned their lessons and then they reiterated that into a new framework, which is awesome.
Logback and SLF4J become the new standard, I'll say, from any of the Log4j fans in the audience here.
Yep.
I was actually just updating the notes this morning as we were talking, realizing that we have some older terminology in here, which, always trying to improve our process here. But the interesting thing with SLF4J is that it becomes a wrapper around the actual logging framework you're using. And it only helps us in that we can code kind of the same way across multiple apps as if they're all using that. And Logback becomes that implementation of the actual logger. But from a framework perspective, thinking in terms of Java, if we're talking about the Spring framework, they can code directly to SLF4J, and they don't care what the actual implementation of the logging framework is. They can let whoever is building the app figure that out and use whatever framework is already implemented in that application. So if you're maintaining a legacy system that has Log4j, SLF4j will just be like, okay, we'll just use that and kind of basically delegate to that framework. And if you're building a newer, framework or a newer application, you can use Logback and, it'll work just the same.
So one of the other things I like about logging frameworks, and I'm kind of famous for this, is a lot of developers use their IDE for debugging. And that works a lot of times for our smaller projects and stuff like that. But when you get dealing with a lot of these enterprise systems, it's really hard to debug things in an enterprise system. And a lot of times you'll have to debug in production. You can't pause the production website. Hold on, let me pause the website.
Breakpoint.
To, walk through things. All of a sudden users are calling the help center like it's locked up. I can't check out and buy stuff, right? Think you're going to be a popular person that day? So what happens is if you're using logging to debug problems, you can then go through the logs and start finding this information. And oftentimes, I'm called in to deal with problems that aren't reproducible or they can't figure out easily. So a lot of times what we're doing is we're going in and we're gathering the time of the problem, right? Here goes the UTC thing, right? Oh, the user said, here was the problem, here's the time. So we go look in the logs, we try to figure out what was going on during that time, and then we try to go instrument more debug. And then as the problems are reported, we keep grabbing the logs for that time period and refining our debug and allowing it to happen, because it's not something, most problems aren't reproducible. If you click on this button, this is what happens, right? Those are the best problems to have in life, because once it's reproducible,
I go create an automated test for that too.
It's pretty easy to go test, reproduce, and know when you fix it.
Right.
But most problems are like, this user says that this happens when they do this, and you go do it and it doesn't happen. And it doesn't mean it's not a problem. It just means that there's some series of events happening behind the scenes.
Yep.
And it might be a resource not getting closed problem. We'll get to that later. But there's a series of problems that could happen. So a lot of times we're trying to debug problems that aren't reproducible, and logging is incredibly helpful for that. Now, remember, quality log statements, having context and improving the quality log statements. You're going to get that one log statement that's gold, and you're not going to know it because the quality of the log isn't there. So make sure you have good quality log statements, but that's where this logging framework helps us. And then once you get into it, you can turn on and off different log levels. Like, oh, I think the problem's here. Let me go turn that logging on in this class in production. So it allows you to drill down, right? And so there's a lot of value in that logging framework. So I would encourage you for school projects or even as you learn, get in the habit of setting up a logging framework. Dustin alluded to this earlier. We make sure we write it to a file. Don't send it to the console. Write it in the configuration for your logging framework. Make sure it's intentionally set to a file.
Yeah. So I would say there's one caveat to that being if you are running in a containerized environment, that is the one time that writing to standard out is okay, because there are certain processes in those containerized environments to pick up that standard out and write it somewhere else to a file.
And make sure you are doing that too.
Yeah. And if you don't have that set up, that's even, I was gonna say that's also pertinent to that environment. I was talking about the elk stack earlier. Part of the process that we run is exactly what I just explained, in that we have our app, we have it containerized, we have it running in an environment that allows those logs in standard out to be basically slurped and spit out to that elk stack, and make sure that's in place. And if you're working in an environment and they don't have all that, and they're just, going into each server and opening up log files and just reading and listening to the log files, that's, there are ways to improve that. And we'll talk about that more in our DevOps talk later.
So I'll jump into log levels.
Yes,
right?
My favorite.
So so we want to talk about them so that it's kind of educating people. From a developer standpoint, most developers just do log everything to debug, right? Everything's debugged for their standpoint, right? And so, we'll give you some guidelines, and then we'll talk about some, it's not an a la carte thing, right?
A little bit of, error here, a little bit of
it's got to be
here.
intentional. Yeah. So I like to say that, and here's how we use them, and I like to push our implementation on people because I am biased, but think it makes sense, obviously.
But I mean, we're always open to feedback. So if you guys have, comments or suggestions, let us know so that we can, take that into account too.
Yeah. And so what we try to do is we try to use errors for, if it's a problem that we should drop everything and fix, right? So like the world is on fire, like the application is clearly not working, our customers are not happy, right? Mm-hmm. And why is this important is what we like to do is we like to scrape our logs and send everything from info above. So there's error, warn, info, debug, and trace. Those are the levels, right, in order. So we like to say scrape everything from info, warn, and error and put it somewhere intentional. And then we like to set up alerts when error logs come in to say, hey, Dustin, error, there's an error. You need to go look at something. There's a fire. Go put the fire out, right? But if we make everything an error, Dustin's going to just get overwhelmed, like on a minute by minute basis, fire, and he's going to
won't get any work done.
Yeah. Well, and he's going to start ignoring it because he's going to realize that they're not true fires.
Yep. Put it in a folder, ignore it.
Yep. So it'll be that little like create a rule in Outlook or create a rule in your favorite Gmail, whatever your favorite email rule of choice is, and then you'll ignore it, and then you might as well just stop doing it once you ignore it. So we treat errors that way. Warnings, those are the ones that we kind of say, okay, the app isn't happy. Right, there's a problem. If a user calls, we want to go look at those because this is probably related to something that's going on there, but it's not a fire. Not drop everything, go figure it out. It's if we have free time, which we never do, right? We'll go fix this, right? Let's be truthful to ourselves. Yep. But it's going to be pertinent when somebody calls. You might want to know something about it, but it's not like it's not something we know is a problem.
Yeah.
Okay. Info is a little harder to find. I like to say we use it.
Yeah.
Go ahead.
I was going to say, I think info ends up being kind of the grab bag for everything else. If it doesn't fit in one of the other areas, it should go in info. But the problem you run into there is knowing what the difference between knowing what the difference between info and debug is. And that's the harder challenge in my mind. Because error and warn, I think, are pretty standard. Like you understand, if it's an error, oh gosh. But if it's a warn, if it's an info or a debug, that's the harder line to draw in my book.
Yeah, I like to use, we found info is really good for answering questions like, especially like security errors, like users are denied access for security reasons. We like to make that info because they're going to call in and our support team's going to need to figure something out, right? And then when they say, well, they can look in the logs, oh, Dustin was denied access for this reason, right? Then they have information to make decision, and it's not a bug. They'll just be able to say, hey, look at, you're trying to do something you're not allowed to do. Go speak to your manager. Or the other thing we like to use it for is tracing data, right? Is when a lot of times we're writing systems that move data around. And so we like to give data a unique ID. And that way when someone calls and says, hey, I haven't seen my data, Well, what's the ID? Then we can go search in the logs, grab that ID, and say, oh yeah, we saw it, we processed it, and here's what
Bing,
happened,
bing,
right?
bing.
So it allows us to have traceability of what's going on in the system, so we know if it's healthy, right? And it allows us to basically info allows us to answer questions when people are going to call and ask about things. So we want to store it and put things out to info that we need. And that's kind of the way we treat info. It is a little bit of a grab bag. And then debug, obviously, debug is a developer thing, right? We don't use debug in production in theory unless we're trying to truly debug something in production, which should be rare.
The one instance that we've recently run into this with for using debug in production has been when we first released an application to production. So we recently did that on my project where an app that we were given, it was a problem. We figured it out, we fixed it, and got it out into production. But part of the process of us doing that was trying to understand exactly what the app was doing. And we, coordinated with the operations team at the time, made sure that we had enough space for these debug logs as it was very noisy. But we needed that on so that, as we released to production for those first, 3 to 4 weeks, we had that level of information for any time a problem did come in. But once that 4-week period was done, we stopped seeing these issues occurring as we were pushing out patches, fixing things. We were able to kind of take that logging level down a little bit, back to our normal of info, error, and warn.
Make sure you pull it back. I've literally seen. I remember one time we were debugging a problem, and they had turned everything on because they weren't sure what the problem was.
Oh gosh!
And I kid you not, I was like, well, just do something intentional so we can see it in the logs, and we weren't seeing it.
Yep.
And then they're questioning what was going on. What it turned out to be is with everything on, our log files were rolling over the 7 gig size every 5 seconds.
Yep.
So literally we were writing out 7 gigs of logs every 5 seconds. And so we weren't seeing our messages because we would try to do something. 10 seconds later, we'd go look and it wasn't there because it had rolled off already.
Yep.
And so if you're generating 7 gigs every 5 seconds, can you imagine how much logs that is? You're going to fill your disk. Now, we have ours automatically rolling off after 8 logs.
Mm-hmm. 8 files.
8 files. So we don't fill the disk. But what was that, 5 times 8, 40 seconds? We have 40 seconds of logging now. That's not useful, right? And these are real world examples, right? I remember the developer when I was working with him on it, I was like, I think the logs are rolling off. Look at the file times. And when we figured that out, he was like, oh my God. Like it was like one of those things we never thought would happen.
Alex in chat, he said, dear God.
Yeah. I mean, we just didn't think that was even a feasible experience, right? And so that kind of leads into the difference between debug and trace. I like to be intentional about things. And so what we try to say is, debug and trace are developer tools. So I like to make trace those statements that are obnoxious, right? That you don't want to see all the time, but if I'm, if it's in a loop or if it's in one of those functions that's called in a loop a lot, make it trace. And if you can't figure it out, make it one level. And with all these statements, right? Here's the thing, right? If you go into a log and you're debugging a problem and you realize that one of these things isn't true, like you debug an error and it's not truly an error, switch it to a warn. This isn't a one and done thing. Software is a living, breathing animal that we have to nurture over time. We have to fix. If you make a debug that, wow, this is too much information, think of Dustin and say that should be a trace.
Yep.
Right? Look, Dustin's on your shoulder. That's a trace, right? And so go change these log levels, right? And so where I'm going with the log level thing is I used to be able to tell what developer was by what logging they chose. Because one guy on our team would make everything a debug, another guy would make it a trace, another guy would make it an info, and that's not the right solution. I shouldn't be oh, that's a Dustin message. It's an info, right? No. Make a conscious decision to choose the level so that the operations team, in which if you're probably part of operations, you can then start parsing the logs and understanding what's going on and finding information easily because operations can quickly consume all of our fun time developing if we don't make intentional decisions with the logging.
Yep. From a real world perspective too, that same application that we just deployed recently, part of my day-to-day job these days has been adding additional logging to the app so that we know what's going on, especially when we're debugging, complicated problems. I recently just wrote some code that had a good set of trace logs all through it because it was doing like looping over the object a couple times that we were, interacting with. And before that, there was no logging. Honestly, there was a system out there. And these are, this is from the part of the previous developers that were on the project.
They didn't add value to the code. They didn't set that in there. So you had to go fix it.
Yep, exactly. So it's been an interesting area of discussion on our team too. Is one of the mantras I've been saying recently is do we add logging to this? Do we have some sort of logs for this? Are we able to actually troubleshoot this in production?
What you should be telling your team is we have a Saturday class for this.
Yeah, I thought attendance looked really high today.
My team gets so mad at me when I reference the Saturday. We have a Saturday class for that. You should come to it. I'll send them a link.
Yeah.
So yeah, be intentional about your logging. Continue to add value to the code, right? And push that value because ultimately, if we want to have fun developing, we need to spend less time on operations and we need to find problems quicker. And that's going to happen if we're intentional with our logging.
Yep.
And we're going to improve that value. And it makes us a better developer. And honestly, most people learn by watching examples. So if you're not doing these things, the people you're mentoring won't do them either.
I was going to say even your peers.
Yeah.
If you become the example on your team, and it comes up in code reviews, that starts influencing the team around you in a positive manner.
Yeah, I love to be like, oh, you should be more like Dustin, right?
From a leadership perspective, yeah.
I love going to like the junior developers. I'm like, hey, junior developer Pat over, he's doing a great job. Have you guys seen his log messages?
From a peer perspective too, it's really interesting to be at that level because if you start impacting that change, especially when it comes to logging, you can say, hey, well, look, in a code review, these are the places where I logged because this helped me debug the problem. And then as you see other code reviews without logging, you can easily put comments in there saying you could add
code review fail.
Yeah, exactly. You can mark it needs work. You can say put logs in these places and you can see what's going on. It becomes a very easy talking point.
Well, and it gets back to that ideal worker conversation we had, I don't remember, a few weeks ago, but people want to work with people that are similar. And so, as we style these virtues to other people, they'll hopefully do them and then they'll make the code better for all of us. And all of us will have more time to code. Right. All of us will, get better. But it also takes feedback too. Like you might during a code review realize that something's a trace or an error that somebody else put a warn because you have more context, and that's fine. Like, don't make it a test. Just tell them, explain to them, oh, I think it's an error because of this, because they might lack some context there that you have. So that's where everybody learns and everybody wins in those situations.
That's a learning point. Yeah, exactly. That's a communication learning point for you as well as whoever you're communicating with. If they don't understand that part of the code or you don't understand that part of the code, have that conversation.
Ask questions.
Yeah, learn the context of that part of the code because then that helps spread the knowledge across the team.
Or read the documentation. All right, am I going too far?
Oh, man. What documentation?
We know there's no documentation. Come on. Yeah, that's the big joke there. So I think we're beating the horse dead there, but I think we've covered most everything here. In the past, there's been some of those wrapper logging frameworks. I've been more of a fan of not using them and using the logging frameworks so that you can get the full features of the logging frameworks, because we've really never switched to logging frameworks. So
the main benefit and we were talking about this earlier a bit, is SLF4J allows frameworks to provide logging in their framework that doesn't, subscribe or prescribe a logging implementation. So that's the big change, is that, some of the wrappers in the past have not been quite as good.
Terrible, yeah.
Whereas like SLF4J, for example, has actually solved the problem in a meaningful way.
Good. All right, so if there's no questions, feel free to throw your questions up there in chat. Pat did post the attendance, so please don't forget to sign in. I usually get 1 or 2 emails afterwards swearing somebody forgot to sign in, so please try to remember to do that. All right, so the next topic is near and dear, exception handling, okay? And this is, we put this in here because we find it's not being taught. We just had somebody, last year came to us and said this was one of their interview questions when they went and interviewed. So they said, yeah, I nailed it. They had just done the Saturday class right after that. So that was kind of neat. So exception handling, and really getting to the finally clause and what that means. A lot of times we try to interact with people on this, but we have to handle it differently through streaming. A lot of people don't understand what the finally clause does. So you have the whole try, catch, and then after the catch, there's a finally. Can we share my screen? I might have to bump the size up. Oh, Lord. Let me check this here. Ooh, let me see.
A little bit. Just a little bit bigger.
That didn't work real well. Let's see if I can put this in like Notepad. Oops. All right, sorry.
Yeah, that's good. That's better.
Is that better? That way I can
think so.
change things in here too.
Yeah, let us know if we need to bump it up at all.
Yeah, that looks pretty good. That's better. All right. So down here is the finally clause. Okay. So the finally clause does is it ensures that everything within the finally clause is executed, whether or not there is an exception. So if there's an exception, the finally clause gets executed. If there is not an exception, it still gets executed. Okay. And why is this important? So a lot of times when you're doing resource allocation, so see, we're creating a new file stream here. That creates that uses a file pointer from the operating system. Okay. If we do not close that file pointer, what happens over time, and it doesn't happen right away, is there's some limited number of file pointers. Let's say 1,000, right? After 1,000 episodes of this, we come to this code and it says open a new file output stream. So the operating system says, I don't have a file pointer. It says, but I'll wait for one. And so it's waiting for one to free up. I'll let you know a secret. One is never going to free up. So what essentially happens is it looks like the computer is actually froze. And then imagine this. You restart the computer and everything works again because all the file pointers are freed up at restart. Okay, does that sound familiar? You know, that's a very common thing that people make fun of Windows for, myself included. But what it really comes down to is poor software development where it's not written to close the file streams. And so it just randomly hangs after some number of days. And so I don't know if any of you guys want to write code like that. I don't want to write code like that. Dustin, do you want to write code like that?
I don't want to have to debug that problem.
Correct. That's impossible, right? Just go search for catch and look for no finalies, right?
Yeah.
I will let you in on another secret. Whenever you want to search for something, searching for the absence of something is extremely hard.
Yeah.
Searching for the error is easy. So searching for something without a finally clause, because it'll find all the catches, but then searching for one without a finally is harder.
Yep.
And so the theory here is we open the stream. So a lot of people are going to complain and they're going to say, well, I did this. Let me change this here. They're going to say, they're going to open the output stream like this, right? Bear with me here. I'm going to comment that out. They're going to open the output stream like this. And then they're going to say, I couldn't do that, Brian, because I couldn't run this close statement. Okay. Because when you put the variable name within the try catch, these brackets,
issue.
Yeah, it creates a scope where it's only valid here.
Yep.
So putting this output stream outside of this, assigning it to null, gives it a scope across this whole try catch block. So that's a very important thing to understand.
Yep.
I get a lot of people emailing me saying, I tried to do what you said, Brian, it didn't work. So create the scope. So then that makes it valid here. Okay, so now opening the output stream, you can write whatever code you want right above it, below it. If there's an exception, it'll go in, it'll execute the exception, which we're trying to throw the exception to exit here. It'll come down here, and now it'll execute this close every time.
Right.
Okay, and so it's very important to understand that finally is required. So anything you're doing, it doesn't have to be a file output stream. Anything you're doing, usually anytime you need a close statement, it should be within a finally, because usually close is the standard terminology used for resource allocation. It doesn't mean always, right? But 99% of the time, you want to make sure that you're closing that.
Yeah.
Okay.
I'll say one of the other good examples, and I don't think we have a code example for this in the notes here, but a good example is when we're trying to parse exceptions from like an external call to a different system. Part of the problem that you run into there is you need that finally block, or in some cases you want the finally block because you can have a response that comes back that is executed from whatever framework you're using and actually throws the exception, but the response is still within that exception body. So being able to parse the potential failure from that, we find is easier in the finally block in case there's an issue in the main processing as well for whatever other reason.
What I hear is Dustin's going to add a new example to this.
Can do. Yeah. So I was gonna say, this is there's just ripe with opportunities right now. That project we're trying to help and solve. But one of the problems that we ran into is that when we're executing our REST calls with our against our other service that we have standing up, it'll throw exceptions for if you have issues with either you messed up the body of the data that you're trying to send it, you don't have access, whatever happens. But we want to actually parse the details that come back, because it'll have all of that good information as opposed to just the status code.
Yeah.
So we find that, the catch and the finally blocks become very helpful for that in order to send that data back to the user in a meaningful way.
Well, and so that kind of throws us into this catch block. If you can share my screen again.
Yeah.
So, there's a lot of debate on right or wrong on this, is what to do within this catch statement, okay? Now, if you notice, what we're doing in here is we're throwing a new runtime exception. So what I like to do is, if there's not an exception, if it's not something we know how to handle, a good one that we know how to handle is like a invalid password error. Like,
authentication.
We know it's an invalid password. We need to go prompt the user to do something with the password. An IO exception where the file wasn't found or something, generally that's it's a software issue. It couldn't find some configuration file, couldn't find some file that the software expected. Found. Yeah, that's not something that we're going to propagate to the user.
The other interesting one with that too is if the software doesn't have permission to write to that file. Yep. And that goes back into what we talked about at the advanced Linux, making sure that people have the right permissions and things like that.
Yeah. And so what I like to do is propagate the errors up and centralize the logging at a higher level, because if you do, something like this, let's just say you have a logger defined, bear with me.
Debug.
No, this is going to be a warn. I'm making this a warn, right?
That was a test.
I'm just going to pseudocode this here. Log IO to error.warn, right? And then we throw it up to the next level. And then the next guy does this. What we end up finding when we do this is we have the same log statement written 400 times in the logs. And it becomes very obnoxious, because you're like, oh my God, this error is happening everywhere. And it's not. It's the same one. So
the problem you also want to keep in mind here is if you keep that log statement but don't throw the exception, that's even worse. So that's a major problem that we call exception hiding.
Well, sometimes exception hiding, this example down below here, looks like this. Yeah.
Where there's no logging, no throwing. If you get a log, that's something at least.
Yeah. And so exception hiding, this is a true scenario. And a lot of times what you'll see is something like this, right? To do add exception handling, right? Mm-hmm. And this is an ID. Usually someone will do one of those try catches with an ID. They auto-generate it.
Yep.
But then they forget to put something in the catch statement. And something as simple as a null pointer, right? Those are my favorite errors, because it gives me a class name and a line number, and we can go see what the problem is, right? Well, as soon as you're missing the class name and the line number, it becomes extremely hard to figure out what's going wrong.
Yep.
And to find this problem because of the exception hiding. Exception hiding makes one of those simple things to fix suddenly very, very hard to fix, because you don't have the feedback. It's let's say a communication problem, right? Or a communication opportunity. Yes. Problems are opportunities here. Yep. But it makes it really hard to figure out, because all of a sudden the software just crashes and then there's nothing in the logs. As a developer, the first thing we want to do is go look in the logs.
Figure out what happened.
And there's nothing. And so what you'll end up doing, and this will happen, I promise you, I literally promise you, if you develop software long enough, you'll track one of these down, and then you'll go look at your revision control system. This is my lead into the next topic, right? And you'll try to figure out who added that code in. And what's the worst thing you're going to find is when your name shows up there, right? You don't want it to be you. You're going to be all mad. Oh, I'm going to track that developer down. I'm going to give him my mind. And you're going to come back to your name, right?
Yep.
So you don't want to be that person. And so avoid that. And there's kind of, there's a methodology for finding these problems too. Yeah, this gets into, so
he's going to ruin the movie.
I do. I have a little, game I put into this. So I'll let me move up here on the editor. Right.
So we'll ask a question for chat here. How many people have actually seen the movie Titanic?
Yes. So line 0.
Because Mr. Walsh this morning is going to ruin that movie for you forever.
Line 1 million. So this is my code.
You will always think of Walsh when you watch Titanic from now on.
You will. Think of me. right? And so let me I'm gonna make this a little more realistic, right? I'm gonna put the statement in here, right? All right. So now, how I try to find and solve these kind of problems is if I have a million lines of code, I'm gonna randomly go try to find, you know, the center of the code. I'm gonna do.
Sorry, Matt.
Someone seen this? All right. I'm gonna put debug, and I'll put, you know, some nice, easy to find, searchable message, right, that I can find when I search. Because then I'm going to go execute the code, and I'm going to see if this message prints out. Okay, if this message prints out, that means that the problem is somewhere in the half of the code from this line down, right? So if this is the halfway point, it's from line 500,001 to a million, line 1 million in the code. So now I know where to look, right? And so what I'm going to do each time is I'm going to then split it in half. I'm going to go to line 750,000, and I don't mean exact, but this is just take a guess in your code, right?
Yeah, we're assuming that this is a 1 million line file here, you know.
So now I'm going to go down around 750,000. I'll put a debug statement in. So what I'm doing is I'm splitting it in half each time, okay? And this is my reference to the Titanic. There's a scene where the main actor and actress in that movie say they're going to meet halfway each time. I don't know if anybody's ever seen the movie, but think of that scene, right? Essentially, we're doing the same thing. We're going to go halfway each time in our code to look for the debug, okay? And so every time you see that movie and you see where they say they're going to meet halfway and they'll never technically get there, if they do that, it's a really romantic moment. Think of debugging code, okay? Because that's what you should think of, is they're really doing the binary search algorithm, right? And so if you're at a movie, just tell your girlfriend, your boyfriend, hey, that's the binary search algorithm. Brian was talking to me about that. Said I should watch this movie for that reason. As I remember, it was a grueling 3-hour movie, which is, I'm not good with movies.
I was going to say, back in those days.
So as we think about the movie, we've gone halfway. So now at line 750,000, now we put a debug statement in. It does not print out. So now we know that the problem in the code is between line 750 or between lines 500,000 and 750. And so now we just split that one in half, right? And what happens is you can start narrowing down that problem very quickly by splitting it in half. You put it, you know, somewhere around 600,000. Now you're quickly, you know, within probably 5 iterations, you can narrow it down and look, oh, now I found the line of code where it's at, right? And so that's how I get to those problems and finding them. You know, guessing in the code or looking in the code for a catch statement that has nothing in it is a hard thing to search for. Code reviews should technically catch these things, right? But we're not all perfect, and we always inherit the code of others, so we have to be able to handle these situations. So think of that Titanic. If you have an exception hiding, just go halfway in the code each time, and it's just an algorithmic binary search. You know, go search and find it. So your computer science teachers would be truly excited that you're using an algorithm to solve one of those problems. So that's how we handle exception hiding. Questions on exception handling. All right.
Did we want to talk about checked versus unchecked real quick?
Go ahead.
Too?
Yeah.
I think it might be good to you know, just touch on that real quick. So you see on Brian's screen before it goes away, or we're not. But anyway, Java itself has the idea of a checked exception versus unchecked exceptions. So checked exceptions are one that you have to declare in a throws statement, or you have to, you know, it doesn't allow you to call the method unless you're handling that in some way. Whereas an unchecked exception, you don't have to have throws clauses, and they will continue to bubble up throughout the call chain in essence.
So the checked ones are the ones that you're required to put, you know, here. So runtime is not a checked exception. So in this function, you would not have to put it.
Correct. Yep. An IO exception is actually a very good example of a checked exception. Common, so one of the things that I know most, you know, Java courses that you'll find online, your college professors probably will talk about at some point, is that when it comes to checked exceptions, those should be the only things that you ever catch. Checked exceptions. You should never, never, never catch unchecked exceptions. But you'll see in our code that we actually do catch unchecked exceptions. We are catching throwable, which is technically the interface that is above all of the exceptions in Java. So you might think it's exception. That's not. Exception is actually a implementation of the throwable interface, being the other type of exception, or the other type of throwable being an error. And I think we might have another module that talks about this, Walsh, and I might be digging into that a little bit.
I think you are.
But in our examples and in our general best practices, we want to catch throwable because that'll catch the exceptions, that'll catch the errors, and that'll catch the runtime exceptions as they bubble up.
Yeah, I mean, I get into the whole, do you want to catch 100% of the errors or just 99%? Because there's a 1% where it's an error versus an exception.
Right.
So the throwable will catch 100%.
Yep. And the big thing there is that if you know that you want to catch the 100% of the time and do something or act on that, it becomes very easy to do that. Additionally, and this is something else that I want to put in the notes too, if you want to write a little note about this too. For Java and Spring specifically, one of the things that they provide is basically global exception handling for REST services. So for example, part of the best practices that we use on our projects is using unchecked exceptions to throw up the exceptions to that high level so that you're only ever handling exceptions at that level. And that should handle your throwables, that should handle your runtime, your other exceptions as well. And what that allows you to do is similar to what we have in our code in our examples here, is that you have the throws and your catch statements, and then that will bubble up to that global exception handling. So then you don't have to have your log statements all across your app. You don't have to have your catch statements all across your app. You can just throw the runtime exceptions or throw the custom exceptions that are unchecked up to your app to inform that global exception handling, what is actually happening within your application. And we find that, we, as part of our, so one of the anti-patterns that you want to avoid when it comes to exceptions is having exceptions and exceptional states dictate your workflow. So most of the time when we have exceptions and we're doing try catches across multiple exceptions, all of those blocks that he's now putting the ... are going to be the exact same. They're going to either throw the exception up, they're going to log it, they're going to do something with it in that you want to, tell the developer what's actually happening. But at the end of the day, they're all the same. So you can collapse them all into what we do with our throwable. So the other thing is that we don't want to have custom like workflow logic where you actually say that, oh, if this exception is thrown, I want to do this one case of, I want to go and, call this other piece of code and do this other complex logic, because then that usually is pretty expensive when it comes to the JVM. Now, granted, I will say, hardware is cheap these days. And so you can always throw more RAM at the problem, but if we can optimize the code and help clean up the code and make, the code better, it's better to do it that way.
I don't know. If anybody wants to pay my EC2 bill this month, they might think it's not so cheap.
Yeah, that's true. That's true enough.
Yeah, so here's the example. I commonly see this is what I see all the time in code.
Yep.
Right? They're doing the same, whatever that same line is. You can roll that up and just do a throwable, and now you've got, 4 lines of code instead of however many lines of code this turns out to be. It's this huge block. And then that's the same with the whole throwable, right? If all of a sudden your function throws IO exception, now you're forcing everybody that calls your method to handle an IO exception, and they don't know what to do with it.
Yep.
So that's why we roll that up into a runtime exception. If there's again, throws password not found exception makes sense because people know how to handle that. But throws IO exception, they don't even know what the IO exceptions are for. So be cognizant of what you're forcing on others.
Yeah, and as a kind of a last note, again, this is kind of the general best practice. There are some cases where you need to catch specific exceptions.
There are exceptions to all these rules.
Yes.
I'm sorry.
Exceptions to the exceptions to the exceptions. So again, going back to when we were calling external clients, for example, or external services, those can throw specific exceptions potentially that have additional information that you want to parse out. that is okay. I think that is like the one time where I might have multiple catch statements on my try.
Oh yeah. There's cases where you should have multiples.
Yeah.
When you're doing different things, right? If this ... is different, then you'll end up with 2 catch statements or something like that, right? Roll up the same ones, that do the same thing, and you can order them differently.
Yeah.
So put the one that's doing something different first, and then put your throwable second.
Precedent, because it'll go through the catch blocks in order.
Yep.
So if it hits that first one, it'll run that one and not run the other ones. So you want to make sure that you have that order set too.
Yep.
Yeah.
Awesome. All right. So if there's no questions, we can move on to our next topic.